I'm going to demonstrate a tool that we have been developing that is an interactive learner for Graphbrain. We have this user interface, and it's running locally, but it's a web interface. So we start the tool locally with a command line, and we specify some existing hypergraph database. In this case, I initialize the tool with this hypergraph that contains extractions of news headers from the Reddit World News aggregator between 2013 and 2017. And the idea of this tool is to generate patterns that can be used to extract structures of meaning from natural language, and to teach Graphbrain about these patterns by example. So basically, let me start with a simple example. Let's say that we are interested in extracting claims from the news headers, and a claim is simply a structure where there is some actor that is stating something, and we can identify who the actor is and what is being stated. So I will create this claim classifier to begin with. Okay, and yeah, and it's empty for now. But so what I will do now is I'm going to use this top verbs exploration mode that simply lists the most commonly used verbs in the database, and it's a nice way to look for something promising. and of course here the first thing that we find says sounds like something that of course can be related to claims. So by clicking it we get a sample of examples of this verb being used in the hypergraph. And here we have this example: Turkey says Holland responsible for Srebrenica massacre as diplomatic row continues. Okay, so this might be what we are looking for. Let's see. This is a claim made by Turkey, and basically this is the claim. So what we do is, yeah, we say this is a claim, and we defined two variables for the extractions. So one is going to be the actor, and the other is going to be the claim itself. And in this case, Turkey is the actor, and the claim is that Holland is responsible for Srebrenica massacre, and so on and so forth. Okay, so we do this by just cutting and pasting the relevant parts of the sentence into the extractions. It is always possible to inspect the actual parse hyperedge here. So we can take a look at the structure of the hyperedge that was generated by the Graphbrain parser for this specific case, and this might help a little bit with specifying the variables and so on. But here I'm going to try to not look at the hyper edges and just use natural text to specify the examples. Okay, so. All right, we have the first case. We're gonna accept it, and we see that a pattern was generated from this single case, and so this pattern looks pretty simple and also very generic, and it just specifies some relation connected by any predicate that contains these two arguments, which is a subject and a relative relation, and the subject is the actor and the relative relation is the claim. And these var structures correspond to the variable extraction that we defined. At the moment, what is underneath this tool is a symbolic learner, and this symbolic learner in simple terms, how it works is that it tries to find the most general pattern that correctly positively classifies all the positive examples we gave it, but does not positively classify any of the negative examples that it is provided with. At the moment, we only have one positive example, which is the one we just created. So it's expectable that we get this highly generic pattern. What we can do now is go to the classifier again. Okay, we have the pattern that was generated. We also have this estimator of the number of current matches from this pattern in the database. So about 20% is pretty high, we can look at a sample of stuff that is matched by this pattern to see what's going on. So this first case, there is this senior cardinal making a claim about Ireland being worse than pagans, and this looks correct. It's what we have in mind, so no need to change it. Again, this is another claim that is correct. Same thing. This hypergraph is very heavy on claims, so it's natural that there are many matches, but we have here this title: Israel bans posting news photos, sex films online. Okay, so this is not really a claim. So let's change this example. Let's say that no, this is not a claim. So we're going to provide the first negative example, and we will accept it and see what happens. Okay, and the pattern has been updated, and the difference now is that the connector part of the pattern was replaced by this structure that now specifies say as a predicate, and in fact it specifies that the lemma that the predicate must have say as the lemma. So which is to say, this means that it's some conjugation of the verb to say, and then this other outer structure, atoms. What it does is that it says that any hyperwedge structure is acceptable at this position if somewhere inside it contains an atom that matches this lemma specification. So this allows for many variations of the verb to say, like has said, had said, and so on and so forth, or just says, and any of those things. So let us look at the classifier again. Take a quick look. We now reduce, like there was a significant reduction here. I mean, this is an estimation based on a sample, so it can fluctuate a bit when it's updated. But we see that we have a drop in the number of cases covered, and this is expectable as we increase, hopefully, the precision of this pattern. And now we have a quick scan, and we see that everything more or less now matches. Let's see. Yeah, and we here, for example, we see how this also works with more complex cases. Like it's able to extract the relevant variables from more complicated semantic structures still. So these patterns are pretty powerful in that regard. I mean, clearly this pattern already works very well. It has good precision. Let's worry about expanding a little bit the recall, the coverage of this classifier. Let us look at the top verbs again, and let's see if we can find something that will help us expand this case. An obvious possibility is the verb to claim itself. So let's look at this. So we have this example: Europe falls out of love with Obama over NSA spying claims. That's not. That's in fact, that's probably an incorrect parse. Claims is a noun in this case. ICE is affiliate in Gaza claims responsibility. This is not, again, this is not a claim in the sense that we have in mind. Claiming an attack, an organization claiming an attack is also a possibility of using the verb to claim, but not in the sense that we have in mind. Mandela signer claims to have had a schizophrenic episode. This is a claim in our sense. So let's try it. Okay. So let's say that this is a claim, and we see that here that we already have the placeholders for the variables that we specified before for this classifier. Mandela signer is the actor, and the claim is to have had a schizophrenic episode. Okay, let's do it, and let's see what happens. I'll accept it. All right, so a new pattern has been generated, and it looks exactly. It's kind of symmetrical to the one we had before. It's exactly the same idea, but now it uses the verb to claim instead of the verb to say. Let's see how well this works. Let's go to the classifier again. Okay. We have the two patterns here now, and we have the samples. So NIA claimed this. Stockholm. Okay, this is a an interesting thing to notice now is that the patterns are numbered. Now we have two, and these numbers are used to indicate when we have the sample matches. For example, we can see which one of the patterns trigger this case. So here it was the second pattern, the first pattern. Like here it was the second pattern again. So and this is useful when we are trying to drill down on a specific pattern. So yeah, this is a new case where researchers claim China trying to hack South Korea, something or other. Canadian cop claims something about that he didn't do. Russia claims to have super weapon. Okay, so this is also working pretty well. Okay, so we have this. Let's stop with this classifier for now. We could keep improving it, but we see here that with just 3 cases provided by a human, by me, it was possible to, from these 3 cases, the symbolic learner was capable of inferring 2 patterns that possibly match in this data set thousands of claims with these extractions of actor and claim. So we see here that this method in relation to symbolic to statistical learner, to typical contemporary machine learning methods, is able to generalize and have pretty good precision with a very, very small number of cases generated by hand. So this, for now, this is a purely symbolic learner. We are working on creating neurosymbolic approaches. We're going to combine the strengths of this sort of pattern matching by symbolic learner with the fuzziness of transformer based representations of language, and we'll have more news soon on combining the two. But for now, I'm demonstrating the capabilities of this purely symbolic approach to learning patterns of meaning. Okay, so enough with the claims. I will try now to create another classifier. This time I'm going to create a classifier for conflicts. So, and we were going to define a conflict as a structure where there is some actor that is the origin of the conflict, and there is some actor that is the target of the conflict, and we can also identify some topic for the conflict. So again, we have this empty classifier, and we're going to do the exact same thing. We're going to explore the top verbs and see what appears promising. So accuses. We already see here that Czech Senate accuses outgoing president of high treason. So this is a conflict. Okay. Well, this one disappeared, but we have the sample. So rights group accuses Burma. I mean, several of these could work. I mean, let's just it's a nice idea to pick a simple sentence to work with. Okay, Turkey accuses Russia of ethnic cleansing. So let's say this is a conflict. Let's define our variables. We have 3 of them. So we have the origin, the target, and the topic. Let's call it the context of the conflict. Okay, maybe better. So let's say that Turkey is the origin in this case. Russia is the target. And the context is ethnic cleansing, right? Okay. I will accept this case. And here we go. We have a pattern that is not so different from the situation we had before with the claims, but it's a bit more complicated. It has 3 arguments, which makes sense because we have 3 extractions. And we see that the third one related to the context exists in a sort of a slightly deeper structure. And if we look at the hyperwedge, this makes sense because the context that we define. Okay, sorry, we already changed the case. So, but yeah, the context that we had defined was. I will go to the cases and look at it. Yeah. This concept of ethnic cleansing was inside of this specification defined by the trigger connector. So yeah, it makes sense that this structure is a bit deeper. Let's see how this classifier is performing with some sample as before. The move could bring Islamist forces within 200 yards of territory controlled by Israel. So this is not a this is not a direct expression of a conflict, and the origin is certainly doesn't make sense that it's this. So okay, let's provide this as a negative example and see what happens. Okay, so. Now we have a predicate based on the verb to accuse, as we've seen before, but now with this more complicated structure. Let's see. Well, we already have a new example here that is classified as a conflict according to this new pattern. So let's see. China accuses United States of B-52 provocation over Spratly Islands. So this is good. Yeah, this is in fact a correct example. Let's go to the classifier again. So let's see some samples. Austria accuses Turkey of calling blah blah. Hamas group accuses Israel of for caving. Okay, seems correct. Moscow has already accused UK, so Moscow, UK is a target, instigating a witch hunt. All right. Let's do another verb exploration. Let's see what else we have here. Threatens definitely looks promising in terms of conflicts. Here's an interesting example, possibly. Egypt threatens to arrest British human rights lawyer Amal Clooney over Deming report. So the origin of this conflict is Egypt, and British human rights lawyer Amal Clooney is the target, and the context is Deming report. Okay, so let's give this as a, let's see what happens if we add this case. Okay, so we have a new pattern now, and it's structurally even more complex than the things we had before, but it might still be too generic. So let's take a look on how this performs. Again, we are going to drill down on this second pattern. So yeah, this Canada's most populous province. Although this is not correct. So let's give it as a negative example. And now we have the verb to threaten being specified, but we see that unlike the previous cases, it's kind of a different structure from this one. So it's not only that a certain verb is specified in the connector here, but it's also that the structure in which it appears is important to specify the meaning. Let's see. Let's take a look. Second. So this is already stuff that we had from the previous. So UNESCO, and the target is here, and the context is World Heritage List. Yeah, I mean, Jewish home leader. The target is government, and the context is Palestinian state. Okay, so this could possibly still be improved, I'm sure, but we will stop here with these two classifiers. Thank you for watching.